Welcome to lesson 11. Pause the video, have a go in your own time, usual thing. There are some issues with this question. First of all, I'm gonna show you the answer. So 5x, they're both just x's, so we can combine them. So that'd be 3x equals 3 over x. I don't like that fraction, I'm gonna get rid of it. It's times by x. 3x squared equals 3. Let's divide both sides by 3. X squared equals 1. Let's now square root both sides. X equals 1 or minus 1. Right, and breathe. This has thrown some new stuff into the mix. Let's circle some things that happened. Some things that happened. This was simplifying. Simplifying, remember, is tidying up. Now, tidying up is a great thing to do when you're solving equations, because if the equation's simple, it's easy to do. So hopefully that just makes sense. And you're like, okay, fair enough. When I see something I can tidy up, I'll do it. And maybe that helps me. Here's a puzzle. Why did we times by x? I'm just going to write it out again because I feel like it could do with being a bit clearer as we're talking about it. So we had this situation. We decided to times by x. The reason we did it, and this is kind of new, is fractions are a problem. They're generally a problem. We're talking generally, but generally let's get rid of them. How do we get rid of it? Well, if we times both sides by x, then we'll end up with 3x times x equals 3 divided by x times x. And I'll just show you the cancelling in red. They cancel, which means we end up with 3x squared equals 3. So that's what happened there. That's how we ended up with this equation. Boom. Does that make sense? I'm going to say one more thing. And the other thing is, why did we divide by 3? Well, because we look at this and we go, I'm trying to solve an equation. And I've got this tool now, which apparently Duncan says is very useful, which is the same thing to both sides. So I'm just kind of looking for opportunities to do things. This is what I meant in an earlier lesson where I was saying the maths is quite creative. It's described as being very logical, and you can break it down as being very logical if you memorize many different techniques depending on which equation you reach, and that can be a very useful thing to do. But the greatest mathematicians, well, not the greatest, but many of the greatest mathematicians have faced unusual problems that no one has ever seen before, which means they can't look something up. They can't go, oh, it's an equation of this type, I'll do this. They have to say, creatively, from my skill set, what could I use that will help me? So to do some of the very best maths, you have to be able to be creative. Anyway, blah, blah, blah. So that's kind of what's going on here, which is, so, and that's, again, what am I trying to teach for these 20 lessons? We're looking at some new skills to improve your maths, and that is spotting when to do things. Oh, look, I could divide by 3, which then gives me 3x squared. They cancel, so I've now got x squared equals 1. So, that's enough waffling. Let me just count this off again. What are the 3 things we just did? And breathe. The first thing is, we did some simplifying. The second thing is, which happened here, remember? Second thing happened here, which is that there was a fraction. We don't like fractions. So you kind of think of fractions as another part of tidying up. And then the third thing we said was, why did we do this next? Well, because we're trying to solve an equation. We're kind of just trying to, so we're just doing stuff that looks like it will make things look easier and lead us to a solution. So there's some learning there. Let's do the next question. Have a go in your own time. And the answers are obviously b equals 5 because we can already see it, and a equals 1. A equals 0. Ooh, I just said it wrong, but I read it correctly. So what's going on here? We know that b is 5, so we can sub it in. A times 5 equals 0. Oh, which means something times 5 is 0, which means that a has to be 0. There we go. Next question. Take your time, be creative, see if you can find a solution to this using the skills that you already have. And if you're stuck and you just unpause, I'm going to give you some clues. Remember the skills we know. We know same to both sides, we know make it look the same, we know tidy it up, and we know by inspection. So maybe one of those will be a big help here. Okay, and my solution would be this. 5 to the q plus 1. I'm kind of stuck with 5 to the q plus 1. Not much I can do with it. I wonder if I can make this look like 5 to the something. 5 squared is 25. 5 cubed is 100. Oh, that's it. 5 cubed. Brilliant. Now I can use by inspection. And I can say, obviously, by inspection, q plus 1 equals 3 minus 1 from both sides, q equals 2. That's your answer. Just a reminder, what did we do here? Why did we turn it into 5 to the third? We did make it look the same skill. A key, important, creative skill to answer more advanced, difficult maths questions. Here's another solve question. Have a go in your own time. What's the square root of 2 times the square root of 2? It's 2. What's the square root of 2 times the square root? It's 2. Let's stick a times sign in the middle, because remember there's effectively a times sign in the middle of all of those. Equals y. So 4 equals y. It really bugs me. I want to write it around the other way. Y equals 4. That's the answer. Next question. Solve. Have a go in your own time. How do we solve this? Answer, we use a trick. Do you remember? Remember I said maths generally isn't about tricks, but there's this one trick, which is if you have two things multiplied together making 0, one of them has to be 0. So x plus 1 equals 0, or x plus 6 equals 0. So now, oh look, we've now got two equations. So let's minus 1 from here, which gives us x equals minus 1 is one solution. Minus 6 from here, x equals minus 6 is the other solution. Sorry, I'll just leave that there for a second longer. I don't want to go too fast. And obviously, if you haven't already twigged, because I'm probably going to keep speeding up as the lessons go by, you can pause the video at any time if you want to look at what's on the screen. Here we go. Have a go at solving this. That's supposed to be an 8. So, we've got two equations and two unknowns. And in fact, there's just one unknown in each equation, so we can just do them one equation at a time. Let's do the top one first. Oh, by the way, it will turn out that x equals 3 and y equals 4. Just in case you are confident with these, you just want to check your answer. Right, first one. Oh, well this is, here we go, we can do this by inspection. I always think by inspection is the first thing I just think about. Whenever I see a question, I think, is there anything really obvious that I can see in a pattern? Oh look, well that has to be 1/3, because a third plus a third plus a third equals 1. Therefore, x equals 3. So that deals with that one. What about this? 1 over something plus 1 over 8 plus 1 over 8 plus 1/2. I'm going to make it look the same. So that'll be 1 over something plus 1 over 8 plus 1 over 8 equals times the top and bottom by 4. 4 over 8, which means, oh my goodness, this is pretty grim. Anyway, so that is going to be 2. That has to be equal to 2 over 8, which is 1 over 4. Therefore, y equals 1/4. Again, you could have solved either of these by rearranging, which is fine. Every maths lesson you do is about highlighting new skills, new techniques. So that's just what we were doing there. And for me, I quite like that as a route for solving that particular type of question. Anyway. Have a look at this, pause the video, see if you can solve it. And if you've just come back and you couldn't do it, here's a couple of clues. We've already done this question twice. But exactly the same question, but instead of being k, it was x. Does that help? Okay, now, so the answers are k equals minus 2 or k equals minus 3. Let's go through it. Well, in theory you can't do it because there's two different objects and there's only one equation. Oh wait, this is the trick. In maths, there's the occasional very rare trick, and this is a vital trick, foundation to all of much of mathematics, how to solve a quadratic. Anyway, so what we do is we factorize. We say k plus. Remember, I've already said that I don't want to spend too long on factorizing quadratics in this set of 20 lessons. That's covered elsewhere, for example, in my other course related to my book. Anyway, so that's how it factorizes. You can multiply it and check it if you like. So one of these two has to be equal to 0. So we can think of that vertical line as an OR. So minus 3 from both sides, k equals minus 3, or minus 2 from both sides, k equals minus 2. Just briefly, because I'm sure that the occasional person is wondering, that is going to be k squared. That is 2k. That is 3k. That is plus 6, which works. K squared plus 5k plus 6. There we go. Yet another solve question. Have a go at this in your own time. And by inspection, 5x minus 1 must be equal to 15 because there's a 1 at the top of the fractions, therefore the bottoms must be the same in order for the equal sign to be true. Plus 1 to both sides, 5x equals 16 divided by 5, x equals 16 over 5. Ta-da! Let's do the next question. Oh, it's a plot question. I'd like you to, you know, let's change it to sketch because that way just make it messy and I'll knock marks off if you make it too neat. I'd like you to do y equals x plus 2, y equals x minus 1. Oh my goodness. I'm actually just going to get started now. Do you want to not pause the video yet? It's up to you because I've got to draw the axes and stuff. Let me draw the answers in. Obviously skip to the next question if you're super happy. Y. Oh, can't see that. Here you go. Y. I think we're probably happy with this one by now. This 1 plus 2, we can always do a little table. We can say, well, what if x is 0? Oh, then y is 0 plus 2, which is 2. Oh, look, that's where that point comes from. We can just do more examples. If it's 3, it's 5, blah, 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 and you end up with lots of points and it makes a line. The one common mistake I see is sometimes people draw a line, it kind of goes like this. And then it kind of suddenly jumps. Or it kind of goes like that, and then suddenly it jumps. That's because sometimes people suddenly start making a mistake in their sums when one of the numbers changes from being positive to negative. So watch out for that mistake. And exactly the same thing here. You can do a little table and show that, for example, when x is 0, y is x minus 1, which is 0 minus 1, which is minus 1. So that explains that point. You can find out more and justify that. This isn't so much an actual like maths question. It's more of a kind of, I don't know what you'd call it. Anyway, I want you to look at this and just, can you describe, can you describe what this means? So pause the video if you want to think about it. The question's going to be, what does the minus mean? What does the Q mean? What does that P mean? The answer is, the minus means flip. So if it's a fraction, you turn it upside down. If it's a whole number, you turn it into a fraction and then turn it upside down. What does the Q mean? The number on the top of the fraction. That's a power. That's like squared. or cubed. What does the P mean? That is a root. For example, a square root, if it were 2, or a cubed root, if it were 3, or a fourth root, if it were 4, etc. Okay. Let's do some calculates. I'll do a little list as per usual. Have a go in your own time, and then we'll go through it and we'll think about it. We can think about it in terms of x to the minus p over q. Let's write out the answers. Squared, that's the 2 is a number on the top, so it's on the top of a fraction, because you can imagine it's on top of a fraction, so it's a power, so it just means times itself, so it's a half times a half, which is a quarter. What does the minus mean? That just means flip, so you need to turn it into fraction, so we need to turn it into fraction first, then we can flip it, so it becomes a fifth. This one, the 1 doesn't mean anything, because that just means to the power 1, which means the number doesn't change, so we can ignore that already. And then 5 to the minus, just flip it. There we go, so that's that. What does the 2 mean? That means squared, that's a power, so that'll be 9 times 9, which is 81. If the number's at the bottom of the fraction, it means it's a root, so that must mean the square root of 9, which is 3. Notice I haven't said or minus 3. Ugh, don't get me started. You'll need to just find it. If you're in an exam, you need to find out what you need to do, whether you need to always do the minus or not. If I had any doubt, I would write the minus, but I kind of didn't mean for you to do it here. It's a long story, let's not go into it. Yeah, so I just want to go back to what I said earlier. So basically, if in any doubt, let's write 3 or minus 3. I think that's a clearer thing. I just want to go back to the earlier thing. So what's the square root of 9? 3 or minus 3. Boom. Let's make that our simple answer. And if I've ever forgotten to give the minus, that was my bad, and I would have lost marks. So this is a simplify if possible, so have a go at simplifying this. In your own time, obviously. Guys, oh look, there's 2 objects. There's an x cubed and x cubed, so there's 2 of them. So the answer would be 2x cubed. This one, oh, x cubed, that's x to the 6. If you're not sure why, remember that x cubed is x times x times x. And then x cubed is x times x times x. What's x times x times x times x times x times x? Well, it's x to the 6. There you go. So that's a way of thinking about that. Oh, it's a function question. Again, I've not got an actual question. Basically, you've just got to kind of look at it and guess what to do. The reason I do function questions like this is because I often think that as you're learning functions, the questions can be really quite weird and difficult to understand. And ultimately, I think a lot of students get their marks in function questions simply by just kind of looking at what's going on, just kind of feeling for the answer, and then over time it starts making more sense. So I like to reflect that with how I teach it, blah blah blah. Anyway, whatever, have a go at this. Can you see I made a mistake? I don't really need the brackets. It's not wrong with the brackets, but it didn't need the brackets, because you can put brackets around a number, can't you? It doesn't change it. Like if I got a 5, put brackets around, it doesn't change it. Now someone might be saying, oh wait a sec, but if this is accounting or management, then that actually means minus 5. Yeah, true. So you could say, oh, I just did that wrong. Anyway. Right, so what's going on here? The answers are Q, 0 and 3. Because, oh look, the number doesn't change. It's exactly the same. So if I were to start using some function vocabulary, I could say the function h simply takes a number and the output is the same number. Got 2 calculates here, one after the other. So just wait until I've written them both and then you can have a go. There you go, have a go in your own time. They're all 9s, by the way. There should be 4 9s. My writing was a bit messy there. And so the answer is 9 and 2 root 9. Happy? Move on. Otherwise, I'll just quickly explain it. Remember this one here. What's the square root of 9? It's 3. What's the square root of 9? It's 3. 3 times 3 is 9. And eventually, if you do enough of these, you realize, oh, if I got the square root of something, if I have the square root of something times itself, then I get the number, because that's the definition. This one here, what's elephant plus elephant? It's 2 elephant, yeah? What's root 9 plus root 9? Suppose you had no idea what that meant. It just looked like a weird symbol. You'd go, well, there's 2 of them, whatever that is. And there you go. It's 2 root 9. That's why that's the answer. Don't need to think about it anymore. It's just obviously the case. Oh, it's another one of these. Make Q the subject. My random capitalization or not of titles continues. Have a go in your own time, then I'm going to do it myself. I want to make Q the subject, which means I need Q on its own, so I need to get everything else away from it, which means I just need to get the -2. So what could I do? I could use one of my skills. I'm obviously going to use same to both sides. Same to both sides. I just want to write it just to kind of reinforce the learning at this point. So then I'm going to add 2 to both sides, which gives me 11 plus y plus 2 equals q minus 2 plus 2. Oh, look, they cancel. That's your answer. Personally, I would want to just rearrange it and neaten it up. I didn't say give your answer in simplest form, but if I had, then let's add the 11 and the 2. But next question. Expand. Can you remember what's the next thing going to be? And simplify. Often this is the form of this question because they're like, we'd like to expand it and simplify it. It's just a thing. I would argue it's mainly a thing because it's an extremely good habit to get into. Right, have a go in your own time. And the answer is 7x squared plus 8x plus 1. I'm now going to show you how I did it. 7x times x is 7x squared. 7x times 1 is 7x. 1 times x is x. You can write 1x, but let's just write x. Running out of colours here. 1 times 1 is 1. Then I can combine these because I'm simplifying, so I'm tidying up, which means when you tidy up, if you've got like lots of books, you put them all on the bookshelf together. 7x squared. Oh, there's 7 x's and there's another x here, which makes a total of 8x plus 1. There we go. Let's do the next question. Next question is a factorize. Have a go in your own time. And the answer is, I need to take something out. Remember, there's going to be a plus in the middle, so it's going to be an x that gets taken out. So it'll be a 1, because 1 times x is x, and then 11x, because 11x times x makes 11x squared. So just in case that's a bit confusing, just to be clear, it's x times 11x plus 1. That's the answer. Got a little calculator here. Got 3 here, so I'll write down the 3, then you can have a go. Take your time. 10, 10, 3. Remember, if there's no number, it means square root. Equally, you might just be used to seeing square root, so you might want to ignore the 2 if it's anything. Well, it just means square root. And that means cubed root. So it's saying what times what times what equals 27. That's essentially what that is. And the answer is 3 times 3 times 3 is 27. And for some reason, when I was planning this lesson out, I was like, oh, there haven't been enough solve questions. Let's do some more. Okay. Right. Pause the video, have a go in your own time. Oh look, by inspection, x must be equal to 5. In case anyone's wondering, that's a function with a one-on-one mapping, therefore that is x equals 5. And in case you're also wondering, have I made any mistakes with mapping in earlier questions? I don't think so. I might have occasionally done it, and if I have, I've done it with a kind of proviso where I've said, well, this is generally true, but I'm simplifying a bit. And if you don't understand what I just said, it doesn't matter. I just realised that someone might be, at this stage, someone might be thinking, wait a sec, he hasn't talked about mapping. Anyway, right, have a go at this question. This is the last one in this lesson. Not possible because we have an x, we have a y squared. Two completely different objects. They cannot be combined because it's a plus or a minus. So we're stuck with them separated. Not possible. See you in the next lesson.